Okay, let's do example C, which is this equation right here. First of all, I noticed that it's not equal to 0. So that's one of the first things I want to do is get it equal to 0 and see if maybe I can use factoring it all. So if you subtract 10 from each side, you're going to get minus 7 here on this side. So A would be 1, B would be negative 10, and C would be negative 7. I'm not going to go through the process with you, but if you do B squared minus 4AC, you're going to get, let's say, B squared. Yeah, I think you're going to get 128. We'll do it over here. So B squared minus 4AC is, you don't have to write it down in your notes because we're not going to use this method, but I just want to show you that that would be B squared is negative 10 squared, which is 100, minus 4 times A, which is 1, times C, which is negative 7. And that's going to be 100 minus negative 28, so that's plus 28. I know this negative cancels out this one. So I'm going to have plus 28, which is 128, which is not a perfect square. So I definitely cannot factor this to solve it. So now what I'm going to look at is, well, if I can't factor it, hey, did you notice that the B value is an even number? We can complete the square. So let's go ahead and do that. So I need to bring the negative 7 to the other side, or add 7 to both sides, because I want to get the x squared term and the x term alone on one side of the equation. So if I add 7 to each side, I have this. And now I'm going to make some room to add a perfect square to both sides of the equation. So x squared minus 10x plus some perfect square is going to equal 7 plus that same perfect square, or my equation won't be equal anymore. And whatever I add to the left, I have to add to the right. How do I get that perfect square? I look at this b value, negative 10, divide it by 2, and cut it in half. It's actually just half of this squared. Whatever this is, half of it is negative 5. And when you square negative 5 quantity, you're going to get 25. So I'm going to have to add the perfect square of 25 to both sides. So now this is a perfect square trinomial, which means what binomial squared, what two-term expression gives me this? What two-term expression squared gives me this? And how do I find that? Well, it's going to be obviously x, and the next term is going to be half of whatever b is here, x minus 5. So x minus 5 squared will give you x squared minus 10x plus 25. Square the first, square the last, double the product of the two. When you double the product of negative 5 and x, you double negative 5x. There it is. And now I have to set it equal to 7 plus 25, which is 32. So now I have to undo the squaring. I may have to do a little bit of erasing so you can make some room on this little tiny board, but maybe I can fit it over here. So undo the squaring by square rooting. So square root this, but don't forget when you take the square root, when you're solving, positive or negative root I have to consider. So I'm going to have that x minus 5 is equal to the positive or negative square root of 32. Well, I don't know if you realize it, but this is actually root 16 times root 2. So this is actually 4 root 2. So this side of the equation, don't forget the positive or negative, which I did. So positive or negative 4 root 2. And what equals positive or negative 4 root 2? X minus 5 does. Can barely fit it in there, but it fits. So x minus 5 is equal to positive or negative 4 root 2. The only thing left to do to get x by itself is add 5 to each side. And I like to put the constant term as the first term and the irrational as the second. So instead, I'll put positive 5 plus or minus 4 root 2. So x is going to equal 5 plus or minus 4 root 2. And that is the solution. Two solutions. Again, this is an irrational solution. 5 plus 4 root 2 is irrational number. It's a decimal that never ends with no pattern to the decimal, right, that goes on. And 5 minus 4 root 2 is another solution. Remember that irrational solutions also come in conjugate pairs. Okay, let's do example 1D. For example 1D, it's really not a quadratic equation. You need to solve a radical equation. And to do this, I need to get the radical expression right here. I need to get that by itself. So I'm going to do that by subtracting 18 from each side. And I'll get the square root of 2x minus 3. is equal to x minus 9. And what I have to do now is I have to undo the square root by squaring both sides. So squaring undoes the square root, and I'm just left with 2x minus 3 equals x minus 9 quantity squared. And to square a binomial, you can write it out as x minus 9 times x minus 9, but I really would like you to get into the habit of when you square a binomial, square the first, square the last, double the product of the two. Square the first, I get x squared. Square the last, I get 81. Because negative 9 times itself is 81. Double the product of the two means double the product of negative 9 and x. So that's negative 9x twice, negative 18x. Okay. So that's what you get when you do that. Square the first, square the last, double the product of the two. I'm going to set one side equal to 0 by subtracting 2x from each side and adding 3 to each side. And that'll give me 0 is equal to x squared, I'm going to put the x term next, minus 20x plus 84. So now what I have to determine whether this is factorable or not. So again, I'm going to do b squared minus 4 times a times c to find out if I can factor this. And in this case, a is, remember, you only find a, b, and c when the equation is set equal to 0. So a is 1, b is negative 20, and c is 84. So let's plug those into b squared minus 4ac to find out what the discriminant is. That's what's underneath the radical sign. So b squared minus 4ac, b squared is negative 20 squared, it's 400, minus 4 times a, which is 4 times 1 times c, which is 84. And this is going to give me 400 minus 4 times 84, which is 336. And when you subtract those, you get 64. And 64 is a perfect square, so I can factor this, and we're going to work on how to factor it. Okay, let's pick up where we left off, where we were solving this radical equation, and we ended up with something that can be factored because the discriminant, b squared minus 4ac, was equal to 84. It was equal to 64, perfect square, equal to 64. So now I can factor this. So to factor this, the leading coefficient is 1. I'm going to look for factors of 84 that add to negative 20. So if they multiply to 84 and add to negative 20, I know I'm going to have two negative numbers. And we can just go through the list of factors, negative 2 times negative 42. That's not even close. I know I'm going to have to get smaller than that. Even if we try negative 4 times negative 21, when you add those, you get negative 24. You don't get negative 20. But if you try negative 6 times negative 14, that works. Negative 6 times 14 is positive 84, but negative 6 plus negative 14 is negative 20. So when we factor that, we have x minus 6 and x minus 14 equal to 0. So that's how that factors. All of this to solve this equation, huh? And then when we're all done, we get a solution of x equals 6 because you set each factor equal to 0. Maybe I did that too fast. So we'll have x minus 6 equals 0, or x minus 14 is equal to 0, using the zero product property that when two things multiply together give you 0, then one of them has to be 0. And if it's this one, then x is equal to 6. If it's this one, x is equal to 14. And we could check. You always want to check your solutions when you're all done and make sure they work. So that's what I'm going to do right here. I'm going to get rid of this and check my solutions. Because sometimes when you check the solutions, you find that one of them really doesn't work, and we call that an extraneous solution. So there is one here too. So an extraneous solution is one that solves the equation, but it doesn't really work, and you plug it in. And let's try plugging in 6 first. So I'm just going to put my answers up here so I'll have them. I know how we got them. So I can clear the board and make some room here. So let's clear. Those are the two solutions that I got. By getting the radical side alone, squaring both sides, and coming up with a quadratic equation, okay? So when we check 6, the square root of 2 times 6 minus 3, add to 18. Does that equal 6? Plug 6 in here also, plus 9. That's what I want to know. Is it equal? So this is the square root of 12 minus 3 plus 18. And does that equal 6 plus 9 is 15? So the square root of 12 minus 3 is 9 plus 18, which is actually 3 plus 18. And that gives us 21. And 21 is not equal to what I have on the other side, which is 15. So 6 is an extraneous solution. I don't count it. I can't use it. So let's see if 14 works. Let's plug 14 into the original equation. So I'm going to put 14 here. Okay. So 2 times 14 minus 3 added to 18. Does that equal 14 plus 9? Replace all the x's with 14. Well, 2 times 14 is 28, and 28 minus 3 is 25. I want to add 18 to that. Add 18. So 5 plus 18. That's what I get on the left side, which is 23. Does that equal the same thing as 14 plus 9, which is 23? And it does. So 14 is a solution. That works. But the x equals 6 is what we call an extraneous, let me spell that out, extraneous solution. Okay, our last example of a quadratic equation, it's not in the form ax squared plus bx plus c. It's kind of in this vertex form with the x plus h quantity squared. So when you see something like that, I know I can get this x plus 3 quantity squared by itself. So that's what I'm going to do here. There's not a lot of room on the front side of the notes. If you want to do this on the back side, you can do that. I know it just found like it was kind of squished in the front side. So you take away 2 from each side to begin. And you're going to have 4 times x plus 3 quantity squared equals 28. And the next thing I want to do is divide each side by 4 so I can get rid of that factor of 4. So divide by 4, and I'm going to have x plus 3 quantity squared equals 7. And the next thing to do is to undo the square by taking the square root of both sides. But don't forget that when you undo a square by taking square root, you need to consider the positive and negative square root of 7, right? So both positive root 7 and negative root 7. So this is just going to end up being x plus 3. X plus 3 quantity squared, take the square root of it, you just end up with x plus 3. So the only thing left to do to get x by itself is to subtract 3 from each side. And you're going to have minus 3. I can put it here, positive or negative root 7 minus 3, but I like to put the negative 3 plus or minus root 7 there. That's fine. So x is going to equal negative 3 plus or minus root 7. And again, this is an irrational solution, so they're going to come in conjugate pairs. One solution is negative 3 plus root 7, and the other solution is going to be negative 3 minus root 7.